Welcome back. I hope you are understanding all these video sessions. In case you are having any difficulties, just click on the I icon and you can revisit the previous videos and come back for this session. In the previous session, we have already designed our FSM as string validator. In this, we are going to validate a string input string if it ends in 100 or 110. And another machine is going to validate a string if its second last symbol is A. So let's begin. So just like in our previous session, we will be designing two machines in this session as well. So first question goes as design finite state machine in which the input is valid if it ends in 100 or 110 over the input 0, 1. The solution will go as step number 1 theory, the definition of FSM. Step number 2 is logic. I is already given in the question, that is 0, 1. Y and N are going to be our set of outputs. And finally, the S is going to be QS to Q5. Now, how this will be designed is we will be seeing in the next page. So let's begin with the design of our state transition function, that is STF. Here we are having QS to Q5 states. QS representing our start state or initial state and Q3, Q5 representing our final states. Now in our finite state machine, we can have multiple final states provided they are a finite set of final states. Here again we are going to see the representations of each state. Q0 is for 0, Q1 is representing 1, Q2 is representing 10, Q3 which is our final state representing 100, and finally Q4, Q5 representing 11 and 110. Here there are two final states because our question had mentioned that the input should either end in 100 or 110. So there are going to be two final states where the input string may end in 100 or it may end in 110. So the sequence of these states may not be necessarily in the same manner as I have designed. Instead, you can have Q2 as 10, Q3 as 11 and Q4, Q5 as your final states representing 100 and 110. I have taken this particular sequence for my comfort and my understanding. You can have your own sequence from Q2 to Q5. So let's begin. From QS, we will be transitioning to Q0 and Q1 as it is the first symbol that we are encountering. Next, we will again transit to Q0 and Q1 as from 0 it is forming 00 and 01 as the string, and we do not have any state representing 00 or 01 in any of these states. Next, we are going to transition to Q2 and Q4 states respectively as it is forming the string 10 and 11. So we will transit to Q2 state representing 10 and Q4 state representing 11. Next, from Q2 state, we will transition to Q3 state which is 100, and from Q2 state on getting 1, we will go back to Q1 state. Next, from Q3 state, we will go back to Q0 state or Q1 state. Next, from Q4, I will transit to 110, that is Q5 state, and 111 will make me stay in the same state, that is Q4 state. And finally, from Q5 state, I will transit to Q3 state because if we get 110 and the next input as 0, the string becomes 1100, which is our Q3 state, which is our also final state. So we transit to Q3 state, or from 110 on getting the next input as 1, we transit to Q1 state. Now let's begin the designing of our MEF, that is our machine function. So here, other than Q3 and Q5 state, each non-final state will have no as the output, and other, that is Q3 and Q5, will have yes as the output generated. So that is our STF and our MAF table. In case the speed of the video is too fast, you can pause, solve the question and check the solution. Now, the state transition diagram again will be based on the state function table and machine function table. We have Q5 and Q3 as a final state as per the design of the STF and the transitions according to the state transition function that we have designed. Next, let us solve an example. Let's take 1110 as the example. Here the output that should be generated is yes because our string is ending in 110, which is one of the valid input strings. So from QS we will transit to Q1, from Q1 to Q4, Q4 to Q4 and finally reaching Q5, our final state, giving the output as Y. Next example, we have 1110. Again, this will also generate a valid output string, that is yes as the output. So from QS we transit to Q1, from Q1 to Q4, Q4 to Q4, Q4 to Q5 and finally from Q5 to Q3 to generate the output yes, that it is a valid string as our string was ending in 100. As you can observe, the first example ended at Q5, our one of the final state, and the second example ended at Q3, which is our second final state. You can try and solve for 0011 as the example. It should generate the output as no. Let's solve the second example or the second numerical saying design the finite state machine in which the input is valid if the second last symbol is A. Step number 1 is theory, the definition of finite state machine. In logic, I is already given, that is A comma B. Our O will remain the same, that is Y comma N, and finally the states will become QS to Q3. Now let us see why Q0 to Q3 are the states that we have decided. So here we can see that second last symbol in our alphabets, that is A and B, will be A. So it can either end in A, where our second last symbol will be A, or it can either end in B, where our second last symbol is A. Right? So here that is why we have Q2 and Q3 states representing AA and AB respectively. We have Q0 and Q1 default representing A and B as the states. So let's begin the transition from QS. Of course, we will be transitioning to Q0 and Q1. Till now, you should be able to tell the transitions that we will be deciding from which state we will be altering to next state. From Q0 we are getting AA. So we will transit to Q2 state, and after getting a B as the next input symbol, we will transit to Q3 state as the string becomes AB. Next, from Q1 we will transit to Q0 state back, where it will become BA and BB will make it stay in the same state, that is Q1 state. Then from Q2 state it becomes triple A, so it will stay in the same state. From Q2 it will become double AB, still the second last symbol being A, it will remain in the same state, that is AB's ending. So it will go to Q3 state, that means one of our second final state. Finally, from Q3, we will transit back to Q0 and Q1 states, because then the string becomes BA and BB ending. So the second last symbol becomes B and we have to go back and trace whether we get the second last symbol as A or not. Let's check out our machine function table. So here, other than Q2 and Q3, that is our final states, all the non-final states will give the output as no, and our final states, that is Q2 and Q3, will give us the output as Y, that is yes, it is a valid input string. Let us check out the state transition function diagram. So here from QS, we are reaching either Q2 state if it is ending in AA, or we reach Q3 state if it ends in AB. Let's check this with an example. So first example that we are taking is QS AABAA. We can clearly see that our string is ending in AA. So let's trace the transition. From QS we will reach Q0. From Q0 we will reach Q2. From Q2 we will go to Q3. From Q3 we will go to Q0. From Q0 we will reach Q2 state and give the output as Y. Let's take another example, BBA. Let's trace this example as it is clearly seen that it is ending in BA. So that means it should give the output as no. From QS I will reach Q1, Q1 to Q1, Q1 to Q0 and output will be no. Let's check another example with a smallest string, that is AAB. Here again it is clearly visible that our string is ending with a second last symbol as A, so it should give the output as yes, it is a valid input string. So let's trace the transition from QS to Q0, Q0 to Q2 and Q2 to Q3, finally giving us the output as Y. Now here also you can observe that we had two final states, Q2 and Q3. So when we trace the transitions, we will either reach Q2 state and give the output as Y, or we will reach Q3 state and still give the output as Y. That means, yes, the given input string was a valid string. In case you have any questions, do put it in the comment section and we can get it resolved in the next session. Thank you.